This topic of sizing and identifying the optimal link bandwidth may often come to network team during the initial DC build stages and more often during the migration scenarios, especially when we build a greenfield DC in separate co-located data center and attempting to consolidate several existing data center locations. Few questions always come up, such as can't we use the existing connectivity? I mean, assuming the target and source data centers are already connected via some sort of MPLS, P2P, VPN over internet connectivity. Or do we need a dedicated connectivity between source and target data centers? And what should be the ideal bandwidth in such scenarios? And will there be any impact due to latency? Also, how do we overcome in case of high latency scenarios? To answer any of such queries from application teams or any other teams, first you should understand the TCP behavior. How TCP functions. How is that TCP sends segments from one host to another? What is the bandwidth delay product and window size, flow control, congestion control? How that plays a role in low latency, low throughput network versus high latency, high throughput networks. TCP in general is developed during legacy LAN networks, functions well in a low latency and low bandwidth networks. In current high throughput network implementations, like we use 100 to 400 gig pipes within LAN and across LANs, and even over WAN, the legacy TCP implementation will not scale to this level. Meaning, though you might have deployed a huge pipe between two different locations, you would have often noticed you are consuming significantly less of what is available. This is not a network issue as often it is misunderstood. Rather, it's simply the way TCP functions. Just to remind you, this is not applicable for any application using UDP. So that's why the window scaling concept was introduced in TCP during later stages. In TCP, usually window size is limited to 64 kilobytes. Hope you know what that means. The sender can push only up to 64 kilobytes of data without receiving an acknowledgement from the receiver. This and the congestion flow control mechanisms will severely limit the TCP based application in using the maximum bandwidth available in the network, even if the pipe is free. So the simple solution is to increase the receive window size of the TCP for more efficient use of high bandwidth networks. This is achieved through window scaling options where it can scale up to 1 gigabytes. Assume you have a 10 gig link with 100 millisecond of round trip delay, and application in both source and destination supports window scaling option. In that case, sender can push up to 1 gigabytes without waiting to hear from the receiving host. That would significantly improve the throughput compared to the legacy TCP implementations. Just a simpler comparison for the sake of understanding. In a legacy TCP implementation, sender application can only send up to 64 kilobytes of data at a point in time in 10 gigabytes link and wait for 100 milliseconds to get the acknowledgement from the receiver. Then send the next data chunk of 64 kilobytes, so on and so forth. So the higher the latency, you barely consume the available bandwidth in the link. I don't want to go any more deeper in TCP and confuse everyone, but hope in high level TCP basics are clear and what limits the consumption of link bandwidth and how to maximize the throughput of an application is clear now. Now coming back to how to size the link, let's take a migration link as an example, which is purely looked at for temporary period till completing the data center consolidation. So you will identify the source and target data centers where the migration or data copy to occur, identify the volume of data to be moved and timelines to achieve the same. This will give a rough estimate of how much data throughput needed per week, per day across these DCs, like 100 TB total volume to be completed in 10 weeks, which means 10 TB each week and 2 TB per day, something like that, to make it simple. So what should be the transfer rate or the link bandwidth to achieve 2 terabytes per day of copy? That needs to be assessed. Also check the existing WAN link if available and identify the unused bandwidth in average and compare the previous data, which is the requirement, whether it makes sense to use the same link. Two factors will motivate to go with dedicated links. such as no sufficient bandwidth available in the existing links to match migration requirements, or production critical applications are running in data center and don't want to disrupt the production path by pumping migration data over the same path. So if the decision is to go with dedicated links, then what is the bandwidth needed? In most cases, we go with 1 gig or 10 gig sort of links in an enterprise environment, depending on how far apart these DCs are located. Unfortunately, there is no formula or a theoretical way of sizing the link. We will have to assess the requirements and constraints, then make a logical decision based on these together with past experience. A rough estimate based on experience is that you may be able to copy up to 5 terabytes per day over a 1 Gbps link with 10 milliseconds of round trip time, round trip delay. But keep in mind, this varies mostly depending on the application or the tool or the method used to move the data between two locations. Also, hope we understood, simply putting 10 gig or 100 gig link alone will not improve the copy timelines or the throughput of the application. The application itself should have the capability to pump the data in high bandwidth environment. Several migration tools currently provide WAN acceleration features within the tool itself. Such feature can significantly improve the throughput by making use of available end-to-end bandwidth. Another one important consideration, you need to look at the end-to-end bandwidth between source and target systems to assess the throughput. Let's say there is a firewall in between and that supports only 1 gig of throughput, or the entire LAN devices in source supports 1 gig. Then it makes no sense to have 10 gig or 100 gig sort of links over the WAN, because traffic is anyways bottlenecked by the firewalls and the network devices in the source. Now let's look at some theory part in case you're interested to know deeper. Let's calculate the BDP first, which is bandwidth multiplied by round trip time in seconds. So let's take an example of a 1 gig link with 30 milliseconds of round trip time. The result would be around 3.75 megabytes as BDP. If both TCP endpoints in source and target supports this BDP value or more as its window size, then theoretically you can use the 1 gig link fully. Obviously, this is without considering the congestion, packet losses, and retransmission and any other traffic using the same link, etc. So in theory, that will give you a copy rate of 460 gigabytes per hour and around 11 terabytes per day. If you apply the other factors and take an approximation, then you may want to consider, or you may want to expect 250 gigabytes of copy per hour and around 6 terabytes per day you can make it. Or even if you want to consider much more conservative figures, please go for it. Again, this may vary due to various other factors which is outside of network control. So please always keep that in mind. So to conclude, understand the requirements and constraints from other teams and existing infrastructure. Be clear on the network and TCP behavior and its limitations. Make a logical design decision based on these parameters and past experience. Also, it's always a best practice to do a pilot test after implementing the link and do a benchmarking for each migration requirement. That should be treated as a standard baseline in case further troubleshooting needed during the migration phase. Hope you got some clarity on this subject, and thank you for watching.